Have you ever wondered how our planet moves through space? It's a pretty big deal, right? We're all hurtling through the cosmos on this giant rock we call home. But what does that movement actually look like? Is the Earth spinning in a perfect circle like a basketball balanced on a finger? Or is it more of a wobbly, oval-shaped spin, something we might call elliptical? It's a fantastic question, and to answer it, we need to think about two different kinds of movement. One is how the Earth turns on its own, and the other is how it travels around our star, the Sun. Let's consider the science. First, let's get our terms straight. When we talk about spinning, we are talking about something called rotation. Imagine you are standing in one spot and you just turn around and around. You are rotating. The Earth does this too, just on a much, much grander scale. It's constantly turning, and this turning is what gives us our day and our night. This motion is happening all the time, even though we can't feel it. It's a steady, consistent spin that has been happening for billions of years. It's like the Earth is doing a continuous pirouette in the vast theater of space. So let's get back to our main question. Is this spin circular or elliptical? The path a point on the Earth's surface follows as it spins is indeed circular. Think about the equator, that imaginary line that goes all the way around the middle of our planet. A city on the equator, like Quito in Ecuador, travels in a giant circle every single day as the Earth rotates. It's not an oval path or a squiggly line. It is a true circle. The same goes for any other point on Earth, from the North Pole to the South Pole. Each point traces a circle around the center of the Earth's spin. It's important to separate this spinning motion from other movements. The Earth isn't just sitting still and spinning in one place, it is also moving through space. This is where things can get a little confusing, because the Earth is doing two things at once. It's spinning like a top, but it's also moving along a giant path around the Sun. These two motions are connected, but they are very different from each other. Understanding the difference is the key to figuring out the shape of each movement. So let's dig a little deeper into what rotation is all about. So, what exactly is this rotation we're talking about? Rotation is the act of an object spinning around a central point or line. This line is called an axis. For Earth, this is an imaginary line that runs right through the center of the planet, from the North Pole all the way down to the South Pole. Our planet is tilted on this axis by about 23.5 degrees, which is why we have seasons. But for our discussion about the shape of the spin, just picture that straight line going through the middle. The Earth spins around this axis once every 24 hours. Consider this. This spinning motion is what defines a day. As the Earth rotates, different parts of the planet face the Sun. When your part of the Earth is facing the Sun, it's daytime. You get sunlight, warmth, and you can go outside and play. As the Earth continues to spin, your location eventually turns away from the Sun. When that happens, you are in darkness, and we call that nighttime. It's a very predictable cycle, all thanks to this constant, steady rotation. It's like being on a giant, slowly turning carousel where one side is lit up and the other is dark. Let's make it simple. The path of any point on the surface of the Earth as it rotates is a circle. Imagine putting a glowing sticker on a globe and then spinning the globe in a dark room. What shape would that sticker trace in the air? It would trace a perfect circle. The size of the circle depends on where you put the sticker. If you put it on the equator, it would trace a very big circle. If you put it near one of the poles, it would trace a much smaller circle. But in every case, the shape would be a circle, not an oval. This is a fundamental concept in physics and astronomy. The rotation of a rigid sphere, like our Earth, around a fixed axis, will always produce circular paths for points on its surface. There is no force pulling the spinning motion into an elliptical or oval shape. The momentum of the Earth keeps it spinning steadily, and the laws of motion ensure that this spin results in circular movement for every part of our planet. So, when someone asks if the Earth's spin is circular or elliptical, the answer for rotation is clear. It's circular. Consider the science. It's awesome. Now, this is where some people get mixed up. We have established that the Earth's rotation, its spin on its axis, is circular. But what about the Earth's journey around the Sun? This is a different kind of movement entirely. This movement is not called rotation, it's called revolution, or more commonly, an orbit. An orbit is the path that one object in space takes around another one. For example, the moon orbits the Earth, and the Earth, along with all the other planets in our solar system, orbits the sun. This is a much bigger journey than our daily spin. Here's the big difference. The Earth's orbit around the sun is not a perfect circle. It is actually an ellipse, which is a sort of flattened circle or an oval. This was a huge discovery made by an astronomer named Johannes Kepler a long time ago. This means that at some points in its year-long journey, the Earth is slightly closer to the sun, and at other points it is slightly farther away. This elliptical orbit is due to the gravitational pull of the sun and the momentum the Earth has as it travels through space. It's a cosmic dance dictated by gravity. So, let's be super clear. Rotation is the spin of the Earth on its axis, which takes 24 hours and creates day and night. The paths of points on the Earth during rotation are circles. Revolution or orbit is the movement of the Earth around the sun, which takes about 365 days and defines our year. This path, the orbit, is an ellipse. These are two separate, distinct motions. It's like a dancer who is spinning around while also walking across the stage in a big oval pattern. The spin is one motion, and the walk across the stage is another. It's easy to see why this can be confusing. We hear about Earth's movement and might lump it all together. But in science, being precise is very important. So when we talk about the Earth's spin, we mean rotation, and that is circular. When we talk about the Earth's path around the sun, we mean its orbit, and that is elliptical. Knowing the difference helps us understand so much more about our planet, from the changing seasons to the length of our year. It's all part of the amazing, predictable, and beautiful mechanics of our solar system. So we've figured it out. The Earth's rotation on its axis is circular, while its orbit around the sun is elliptical. But why does this matter? Why is it important that the Earth's daily spin creates these circular paths? Well, the consistency of this circular rotation is what gives us the predictable rhythm of day and night. Because the spin is so steady and the path is a repeating circle, the length of a day is very, very consistent. It's not like we have a 20-hour day followed by a 30-hour day. It's always about 24 hours. This regularity is incredibly important for life on Earth. Think about it. Plants have adapted to this cycle for photosynthesis, opening their leaves to the sun during the day. Animals have developed patterns of hunting, sleeping, and migrating based on this reliable schedule. Our own bodies have an internal clock, a circadian rhythm, that is tuned to this 24-hour cycle of light and dark. If the Earth's spin were wobbly or irregular, it would be much harder for life to find a stable rhythm. The circular nature of the rotation provides that stability. Imagine if the rotation were elliptical. This would mean that the speed of rotation might change, making days and nights of uneven lengths. Our clocks would be a mess. But because the spin is circular and at a nearly constant speed, we can build our entire system of timekeeping around it. We divide the 24-hour day into hours, minutes, and seconds, all because the Earth's rotation is so wonderfully dependable. This circular spin is the master clock for our entire planet, a timekeeper for billions of creatures, including us. In conclusion, when we ask about the shape of Earth's movement, we need to be specific. The spin on its axis, our rotation, is circular. This is the motion that gives us the steady beat of day and night, a rhythm that life has danced to for eons. The journey around the sun, our orbit, is elliptical. That's a different story for a different day, one that explains our seasons and the length of our year. But for the daily spin that turns our world from light to dark and back again, you can be sure of one thing: it's a circle. And that's a pretty cool piece of science. If you enjoyed this video, please like and subscribe for more science content.